Okay, how do we find the critical value of Z, or for that matter, even T, when they're asking if we're doing the confidence intervals by hand, okay? Or if they're asking you to find like an 80% confidence interval, something obnoxious. So um, you can always use your Z-score table. You just want to think about the tail area, and I usually use the lower tail area because see this table tells us area to the left. So if I want to find, say, an 82% confidence interval, what I'm going to do is think about, okay, let me get a pen going here. I'm looking for an 82% confidence interval. I want the middle to contain 82% of the possible sample means. Well, 100 minus that, or 1 minus that, is what, 0.18, and then half of that's 0.09. So the area below is 0.09, the area above is 0.09. So then we got to go inside the table and try to find something as close as we can get to 0.09. Let's see here, 0.0. You'll notice that's too small. That's 100 times too small, right? 0.09, right? So then let's keep going. So this 0.09, that's getting small, small. That's pretty darn close. Now that will, let's see, this Z-score, I'm just trying to do it the way these textbooks think. This Z-score will capture, won't be quite big enough because we want the tail to be 0.09, and the tail is actually 0.091. So we've got to really slide down and do the next one down. So the critical value of Z would be negative 1.3, what column is that? 05. So 1.35. Damn, let me get that right. Okay, so that's the best we can do. That would be for an 82% confidence interval. Pain in the butt. So we'll do another way in a minute. But what if you're just looking for a normal everyday confidence interval and you don't like 90, 95, or 99.99% confidence interval? See this little mini table at the bottom of Dr. Stevens' table? This is a really great feature. I've never seen this in another textbook where they make. So that's what he did is he went through and found, let's see, 10% outside to 0.05. He scrolled down and found 0.05, and you see actually 0.05 right there. You see how that's let's see, that would probably be the 99% confidence interval, right? 2.575, yeah. So do you see what he did? He did the work for heavy lifting for us. And if it's a Z-score for proportions or for a place where you know a quantitative variable where you know the population standard deviation, just use this. These are Z-scores. And if they want something else, like you're dealing with myope math and they're asking you with another thing, you can certainly use a table like this. However, let me no, I'm gonna have to stop the share for a minute. Let me pause this video. This computer is acting weird. So now, because if I'm looking for a critical value of Z, we want to use a Z-score calculator, and David Lane works slick. So what we want to do is use the value from an area because we know the confidence interval, right? We know the confidence level. We're just trying to find the Z-score that does it. So in here, you want to do value from an area because we know the area is a probability. We're going to do 0.82 is it for an 82% confidence interval, and mean 0, standard deviation 1 because we're on the standard normal curve. And you see how it gives us those two. And I think what were we getting with the table? 1.35, and a little bit more exact here with the calculator, okay? And so the critical value of Z is the 1.341. Sometimes people get confused with the little what's it called? The little subscript with Z star alpha. Let's see, what's an alpha? It's an alpha divided by 2. That just tells me alpha is the error. So if I got an 82% in the middle, outside of that is 0.18, and if we divide that, that's the alpha. We divide it by 2, we get 0.09. So we're looking for the z-score that has 0.09 probability to the left of it. Or we say 0.09 probability to the right of it. If we wanted to go with the positive z-score. And that's all. That's why they use that notation. Okay. So Dr. Stevens' table is the easiest way with a little mini table. Otherwise, use this. Use this. Okay. Now, what if it's a t-distribution? So with the t-distribution here, this is a nice clear screen. Let me write that here. When they talk about the t-distribution, so it's t star. Remember, use the t-distribution when we don't know the population standard deviation, and either this parent population is normally distributed, or we have a sample size bigger than 30. Okay, those are the two conditions. And if we have a non-normal parent population and the sample size is less than 30, we need to find another technique, and those are called non-parametric techniques, and we're not going to do those in this course. Okay? That's a Stat 2 topic. So then what they'll say on they'll say degrees of freedom, they'll have a DF. No, actually, I think what they almost say is they'll say alpha divided by 2 degrees of freedom. So they'll have all that notation. So if you've watched anything else about the t-distribution, as your sample size gets closer and closer and closer to 30 or bigger, it basically approaches the z distribution. So the degrees of freedom is measure variability. So there's a couple of ways to do this. If you have, I will never ask this of you on a test. Now, the MyOpen Math might ask you, and you'll want to do it this way, or you can just leave it blank and not worry about it. I mean, use that Rossman Chance calculator to calculate it. Not to calculate the t-star, but use the confidence interval. So what if you do a MyOpen Math assignment and you need to find that critical value of t? Well, if you have a graphing calculator, and I don't want you to go out and buy one, it wouldn't be worth it. Here, I'm going to have to stop my screen share again. Pause the video. Okay, so if you have a graphing calculator, TI, the way you access, it's called an inverse T. In other words, you're undoing finding the probability for the t distribution. What you do is you do second distributions, and then you see that number 4 inverse t. You can either come down to it or type a 4. And it's asking you, what's the area? Now, this is the area to the left, or you'd have to do it to the right. Doesn't matter, but you need that tail area. So for 0.05, that means we're looking for a 90% confidence interval. Then you're going to specify the degrees of freedom, and then you can just come down and paste it in. So it's the tail area. I like to use the left tail area, and then the degrees of freedom. You hit enter, and that's the z-score. And we just don't worry about the negative, right? So a t-score, I misspoke. A t-score of 1.714. Now the z-score for a 90% confidence interval is only 1.645. So you see how that, because we only have a sample size of 23, there's a little more variability. And if we go to, as we get closer and closer here, let's do this. But since I'm recording the video, and you can stop it if you don't want to watch this, what if I have a sample size of 50? We know the z-score has a z distribution uses 1.645. What happens with the sample size of 50, which is pretty large? You see how that's getting closer and closer to 1.645? It's still a little bit of variation because, well, this would be a sample size of 51, right? It's 51 degrees of freedom, or 50 degrees of freedom. But see how it's getting closer as that sample size gets bigger. What if we go up? Let's go up to 1,500. That's a huge sample. What's that z-score? See how it's getting real darn close to 1.645? So if you go find another video, I think I have made some about how the sample size gets large, the t distribution is really close to the z distribution. But WebAssign wants you to use the t distribution. That's why we have that great little Rossman Chance calculator. here. And there's other ones out there. If you don't like Rossman Chance, you can go find them. Am I recording? Oh, okay. I don't have my headset plugged in. Hopefully the computer's working. All right. No, then, what if you don't have a graphing calculator? Let me check this. So what I have here somewhere I found is this. I just Googled, here you go. I just Googled inverse T calculator, and these two came up, and this one actually looks pretty promising. All you got to put into it is the degrees of freedom. What was it? It was what did I say originally? 23. Then put in your level of confidence. What's nice about this is you don't even have to worry about tail area. Calculate it, and there's the you want a two-sided z-score here. The one-sided will be when we run next week. We run statistical tests. Confidence intervals are always two-sided because you got those two tail areas. You want to be in the middle, right? You want to get the area in the middle. So see how that's the same as what the graphing calculation is. Okay. All right. Hope this helps.